This is worksheet 4 of the periodic table packet. Again, you're going to want to have out something to write with and also a highlighter so that you can make your worksheet look just like mine. Once I've gone through this video, you're going to want to also go through the video where I have you label your periodic table, because some of the things I'm going to refer to in this video are really easier to see when you have a periodic table in front of you. And I will either assign you to answer the questions on this worksheet after you watch this video, or I may tell you that we will do them together in class. So, you are going to learn over the extent of this entire course that the periodic table holds a huge amount of information inside of it, and you just have to know how to access that information. And today we're going to start by talking about a couple of the pieces of information that you can find on the periodic table. There's lots more to learn, but we're not going to do it all today. So, the first thing to know is that along with all atoms having different numbers of protons, they also have different expected behaviors. So, the element neon is not going to behave or have the same characteristics as the element sodium, right? And this actually has something to do with the number of protons they have, but even more to do with the arrangement of their electrons in the electron cloud. Now, how exactly that arrangement of electrons affects their behavior, we will actually get to in the next packet. But the person who created the first periodic table, Dmitri Mendeleev, actually arranged the atoms by their mass, how much they weighed, their protons plus their neutrons. And that worked pretty well. It categorizes them pretty well by their behavior. Okay, so here's Dmitri here. But just a few years later, a guy named Henry Moseley came along and discovered that each atom has a specific number of protons, the so-called atomic number, right? And so he reorganized Mendeleev's original periodic table so that instead of organizing by mass, the elements are actually organized by their atomic number, the number of protons they have. And this organization actually works a little bit better in terms of grouping common elements together. So the periodic table that you're going to be using in this chemistry class is actually Moseley's periodic table, which is an improvement upon the one that Mendeleev first made. All right. So if you look at your periodic table, you will see that you can look at elements in columns. Okay, so columns go up and down. And you can also look at elements in rows, horizontally back and forth. Okay, so we have a little bit of specific vocabulary here. Okay, the horizontal back and forth rows we call periods. So what we would normally refer to as a row, when we talk about it on the periodic table, we'll call a period. Okay, and what we would normally think of as a column is going to be called a group or a family. And it doesn't matter if you use the word group or if you use the word family. It really means the same thing. Okay, now how are you going to remember this? Because you do need to remember this. I think about when I write a sentence, I write it horizontally, right? Back and forth, not up and down. And I end it with a period. So row, horizontally back and forth is a period. And I don't know about you guys, but when I have a big group of people over or my family over, a lot of people, right? Like maybe Thanksgiving. We don't have a lot of room in our kitchen, so we take them down to the basement where we can put a nice big long table. Okay, that's where I put groups or big families. We go down to the basement. If you have a better way of remembering it, more power to you, but that's what I do. Okay? All right, so if, for example, we look at the first family or group on our periodic table, it starts way up at the top with hydrogen, and then there's lithium and sodium and potassium and all on down in the vertical column, right? So all of these elements have common behaviors. Turns out all of them in this particular group are really reactive. So what does that mean? Let's say I take sodium or I take potassium and I plop them in some water. They're going to go nuts. They start flaming, producing a bunch of heat, all that. Okay? This actually has something to do with how their electrons are arranged, but again, we'll get to that in the next unit. Okay, so moving on a little bit more down here. Okay, we will label this shortly on our periodic table, but basically all elements on the periodic table can be divided up into metals, nonmetals, and then a funny group called metalloids. Okay, if you look on your periodic table, and when we have it in front of us, it'll be a little bit easier to see, there's a dark, bolded, sort of stair-step zigzag line over more on the right side of the table. Okay, and that zigzag or stair-step line is actually the divider between the metals and the nonmetals on the table. Okay, so with the exception of hydrogen, which is actually a nonmetal, so don't let me confuse you here, but except for hydrogen, which is way over on the left side and is a nonmetal, all the elements on the left side of the table are metals. Okay? Over on the right side, to the right of that dark stair-step line, are the nonmetals. So they're over on the right side. Okay? And the writing for this is actually on the next page of your worksheet, but there are also metalloids, so those are the elements that are sort of touching that bolded stair-step line. Okay? So metals are all going to be shiny once they're smoothed and cleaned and polished and all that. They're going to be solid at room temperature, so you got to heat them up if you want to melt them. Okay, and they're good conductors of heat and electricity. Okay, so heat and electricity can move through them. I think we all know this, right? It'd be hard to convince somebody in the middle of a lightning storm to go out on a golf course and hold their metal golf club up in the air, or a metal-topped umbrella up in the air. Okay, why? Because if lightning strikes, the electricity is going to move right through that metal into your hand. Okay. Also, your stove, right? What are you cooking? Metal pots and pans. Why? Because heat can travel from your stove through the pot and pan into the food you're cooking. Metals are also what we call ductile and malleable. So we can pound them into thin sheets if we want to make like heating ducts, for example, and we can draw them or roll them into very thin wires, right? So the electrical wiring in your house is usually copper, okay? Also, you can make them into nice pieces of jewelry because they're ductile and malleable. All right, on the other hand, our nonmetals are usually gases at room temperature. Or if they are solids, they're not shiny. They're sort of brittle, easily breakable, dull-looking solids. Okay, so like if your parents have ceramic or porcelain dishes, that's a nonmetal, right? What do I mean by brittle? Well, I mean if you drop it on the ground, it's not just going to like bend a little bit, it's going to shatter. Okay, while you take a piece of aluminum foil that's a metal and you drop it on the ground, it's not brittle, it's not going to shatter. All right? Okay. And nonmetals, the opposite of metals, they're poor conductors of heat and electricity. So heat and electricity can move through them, but usually not very easily. Okay? The metalloids, which are written about on the next page in your worksheet if you want to turn over there and look at it, metalloids are kind of a funny thing. They're the ones that are touching that stair-step line. And they usually have a mixture. They have some properties of metals and some of nonmetals. So a metalloid, for example, could be something that's sort of dull and brittle, like a nonmetal, but it actually, for weird reasons, conducts electricity really well, like a metal. Okay, so there's sort of a little combination there, which is a little funny. Another important group to talk about are the transition metals. Okay, so right in the center of your periodic table are some columns labeled with B's rather than A's. I'll point this out when we've got the periodic table in front of us. And we refer to those as transition metals. And they're going to be important to us in this class as sort of the rule breakers. A lot of the patterns that we can see in the rest of the periodic table that we'll start to learn soon here get kind of broken with the transition metals. They don't work so well anymore. Okay? All right, that's all for now. Some of this will be a little bit more clear once we can go through with a periodic table in front of us and label this, and we'll practice some of this information later when you get to class.